Okay, so we're back this week and we're going to be covering interactions. And so interactions are really difficult to interpret, and that's really the main difficulty. On the analytical side, when you actually do this in statistical software, it's pretty easy. I think it's a lot easier in R than SPSS as well. So the first thing we'll do, you want to make sure you have your project loaded. And I have imported the data set. So 51 rows or observations, 9 variables or columns. And last week I was saying how we prefer to work with factor variables. So the first thing I'm going to do is create a 10th variable that is area as a factor. Now in R, you don't actually have to make the interaction term by like creating a new column where you multiply it. That's very unusual for R programmers. You're going to see us usually just add it. So I have teacher pay area factor, and then their interaction is going to be plus as a new variable and then just multiply. So really that easy, really no reason to multiply them and make a new column. You can do that, it is equivalent. But notice here, look, if I wanted to create these in R explicitly, I would first have to create dummy variables for the area factor variable, 4 categories, 4 dummy variables. Of course, you only need really 3, so you can get away with just creating 3 if you want to leave the omitted out. And then I have to create 3 new columns where I multiply teacher pay by each dummy. So, but notice how much easier and quicker that is. And so that's why you really won't see people explicitly creating them by creating new columns. And it's pretty easy to do it that way. I'm sure you can figure that out. If you can't, then shoot me an email. Now, we didn't set the reference category, and so it's automatically chose. I can't remember I'm not sure. So randomly chose one of them as a reference category, but we can actually tell R, hey, let's re-level this area factor and let's choose the Northeast as the reference category. And so when we do that, the Northeast will be the omitted category. Notice the interaction terms, it's the same omitted category. So all of that kind of trickles through, really easy to change. Now, again, there's 3 different coefficients related to this interaction effect. So this does not tell you, this row of data does not tell you whether the categorical interaction between area and then the continuous variable teacher pay matters for predicting SAT verbal scores. This just tells you that the slope, well, let's see, this one's significant. So this would mean that the slope between Northeast and Southeast is statistically different. So it's that the Southeast has a more negative slope. And so if you wanted to get to the Southeast slope, you would have to take teacher pay. This is the slope for Northeast because it's the omitted category. And then you're going to basically have that negative 0.68, and then you're going to add a negative 0.73. So the slope for Southeast is way negative, whereas the slope for Northeast is almost 0. And so, but again, that doesn't really tell you whether the interaction is significant. That tells you basically, does the slope differ for the reference category and this dummy category, Southeast? So how do we do that? Well, we need an incremental F-test. I want to simultaneously test whether these 3 interaction terms, which belong to the same interacting variable of teacher pay and area, I simultaneously want to test those. So I'm going to use an incremental F-test, right? So how do we do that? Well, we're going to block this out into 2 different models. So mod 0 is going to be the non-interaction model. Mod 1 will have the interaction. So I estimate both of those. And then I use the ANOVA function as we've been doing to compare. And here you can see just barely not significant. So overall, this interaction is not significant. So, again, you want to be careful about interpreting the coefficients table because, this tells you a more drilled down version that Southeast is different than Northeast in terms of the slope for teacher pay. So that's how you test the overall interaction effect. And it is a bit strange, right? I mean, this is significant there, but the overall interaction test is not. It really depends on your research question. If you're really interested in this and the difference between Southeast and Northeast, okay, you can report that. But if your overall question is the interaction significant, then this would be the ANOVA output right here. That's really the correct p-value to interpret. I will say, 51 cases, interactions are hard to detect, which we talked a little bit about in the lecture. So, 51 sample size, the p-value is low, but not under 0.05. I would say there's evidence of interaction here, but I don't know, it really depends on the personalities that you're working with, your advisors, or if it's journal, the journal editors. I wouldn't mind if you said there's limited evidence here. It's just that it's an underpowered test is why it's not significant. So remember, not finding significance does not mean no effect. It just means that in our sample, we haven't found evidence of effect. It's never 100% this or that away. Now, what about continuous variables? Well, couldn't be easier. It's really the same syntax. So percent taking in there now, you multiply it, you can get the interaction that way. Now look, percent taking and teacher pay are both continuous variables. So you need one term to add the interaction. So I got a p-value there. If I were to block this out, I would get the same p-value if I use this blocking approach. And then finally, what I am showing again is you can make interaction terms explicitly by multiplying them and then saving them in a new variable. So here I make an 11th column. It's a numeric variable, and you can do it that way too. But typically our users will be up here doing it this way. Alrighty, thanks for listening today, guys.